So what are radians? We're going to finally go over what those are in this video. So radians do have to do with the arc length. So that's probably the biggest deal. We're used to degrees. If you look at the unit circle, picture this being the unit circle. This angle represents the degrees as we go around the unit circle for a total of 360 degrees. Now, what does radians represent? It represents the portion of the arc that is associated with that angle. And it's actually 1 radian is equivalent to 1 unit of the radius, whatever the radius is. So as we go through the unit circle, the radius is 1. So each unit of the radius is actually, or each unit of the radian is equivalent to the radius. And that's what you see here in blue. This would be equivalent to 1 radius of the circle going around. So that's technically what they are, but think of it more really as the arc length. So we're talking about the length of the arc. And so with the unit circle, you can picture this being our angle theta in degrees. So this portion right here will be our radians. That's what the radians is talking about, that arc length. So what's an entire circle? The unit circle has a radius of 1, right? So the circumference of the unit circle being 2 pi r would be 2 pi times 1 or 2 pi. So that's our circumference, is 2 pi, since our radius is 1. So in this case, the whole circle is 2 pi. So just to get an understanding of radians, half a circle will be 1 pi, right? Now, how do we figure out the radians? How do we convert from degrees to radians? Well, it's going to take a proportion. And so what you would do with that proportion is you would take this angle, theta, put it over 360 degrees, and it's going to equal our radians. I wouldn't want to call it R. So what would the measurement be in radians? So we know that we have theta, whatever that angle is, out of the 360 degrees. So let's just call it arc length. We'll call it A, right? And so that measure of the arc, the whole circle, as far as arc length goes, though, the circumference of the circle is 2 pi. So if we want to convert radians to degrees, everything comes from this proportion right here. And we're going to break this down into a more simple formula. So if you want your degrees, given the radians, if you want your degrees, multiply the 360 over, and theta is going to equal A times 360 over 2 pi, and if you simplify that, will be A times 180 over pi. So I want to make this 180 over pi clear. That's really the formula. That's really what we're focused on right now. So if you want to change your arc length, our radians to degrees, you multiply by 180 over pi. Well, let's say you want to change your degrees into radians. So let's solve for radians here by multiplying the 2 pi over. So A is going to equal theta times 2 pi divided by 360. Simplify that a bit, and you'll see this formula really similar. It's going to be pi over 180, just the reciprocal of the formula. Going backwards, it makes sense, right? And you'll see this is radians. This is giving us the pi. When we multiply by pi, it's going to put pi into the formula, putting us into radians, compared to when we're in radians, and we want to go to degrees, dividing by pi is going to cancel out the pi's. You're going to see in these problems. And that's how I remember it. If we're going to degrees, we want to cancel out pi, so we divide by pi. If we're going to radians, if we're going to radians, we want to get pi, so we multiply by pi. And that's exactly how we're going to remember it here. But the formula, this is the main part. So let's convert this from radians to degrees. So we're in radians. We want to get to degrees. So I'm going to multiply, this is what I'm talking about, 180 over pi. Because I'm going to degrees, I want to get rid of pi. So whenever I multiply by 180 over pi, by dividing by pi, that's going to cancel out our pi from the 8 pi over 9. And we're going to be left with, we got to simplify this, 8 times 180 over 9. So you can see that the pi's will cancel out. That's nice. And then 9 and 180, don't those simplify? So 9 goes into 180, I think 20 times, right? Because 2 times 9 is 18 times 10. So we're going to go 20 times. So 8 times 20 is 160. And just to double check that, I don't want to be wrong here. So 180 times 8 divided by 9, 160. So that's good. So the main thing there, you multiply by 180 over pi. What if we want to go from degrees to radians? So radians usually has pi in it, right? So I'm going to multiply by pi over 180, so that way we'll have pi in our answer. Not going to divide by pi because that would get rid of it. We're going to multiply by pi. And so that's going to become 70 pi over 180. The zeros cancel out. 7 and 18 don't have anything in common, so 7 pi over 18 will be the answer there. So pretty simple formulas to use. That's pretty much it.